All right, welcome to our demo. This is a demo for our proactive AI agent showing how Grepr can proactively prevent issues with your application. So the way that this works is we've set up a demo application here that allows you to go and buy some items for, I guess, watching the stars. And this is based on the hotel demo that's used for tracing, but here we're using it for our AI agent. So this e-commerce application, there's a bunch of microservices. It has some bugs, and this demo will show how Grepr's agent works to help with this. The other thing that we have is that the logs from this application are going into Datadog so that we can see what's actually happening here in it. So let's first take a look at how the agent pipeline is set up. This is the agent pipeline that enables the agent to monitor and take actions. The first piece of this agent, so first there's some parsing here, but the first piece of the actual specific agent processing is the Sessionize tab. Here, we create transactions out of logs that belong together. In this demo, we're grouping log messages together that belong to the same service and the same hotel span ID, the same trace, basically. You can ignore this ref1, it's used to make the demo repeatable. Alternatively, these IDs could really be anything that you might want to describe loosely as a transaction. It could be thread IDs or IP addresses over some period of time that interact with each other. It could be user IDs, anything that you can use to stitch together a bunch of, say, log messages that indicate a particular transaction in your system. And ultimately, when we group logs together this way, we are really telling Grepr, here's a behavioral unit that you can use to determine what behaviors are similar and which are new versus old using its pattern detection. Now, the pattern recognizer next is really the core IP that Grepr uses to enable detection of new patterns in the system. Using this capability, Grepr understands when to invoke an LLM or the agent and when not to, by only focusing on emerging behaviors. This massively reduces costs and makes using LLMs for monitoring the entire production systems feasible. Otherwise, you can't really be sending all of the logs and asking an LLM and an agent to look at it. It would not be feasible. So this capability takes groups of logs that we've created earlier using the Sessionize step, and then it compares each group as it's coming in against previous groups to determine if it's more of the same thing, it's the same pattern of behavior happening over, or if it's something new that should be further analyzed using the agent. Now, finally, the AI configuration is really where we set up what we want to do with this data. So first, there's some model selection that you can use here. You can use your own models if you like. Here, we're using Gemini, but you can use anything that you want. You can connect and integrate here. Then you set up an LLM prompt here. This describes the user's intent about what's important to the as an SRE. So it's written in natural language. Note that it's not an imperative rule saying exactly what log messages should be looked at, what thresholds to set, what specific errors you should be looking at. It's actually figuring out mostly on its own what are the things that might be interesting or the things that are important. You're just telling it, here's the important things that we're trying to do. In the output section here, we define what we want the output of the agent to look like so that downstream services may be able to use it. In the context section over here, this section allows the agent to make decisions on how it should build memory of what is actually happening in your environment so it gets smarter over time. On the actions part over here, this describes the tools that the agent is allowed to use. So it can use Grepr specific tools like masking rules for masking sensitive data as it's passing through. It can use tools like MCP servers, and here we've set up PagerDuty as the MCP server. And we'll be adding plenty more over time as time goes on. And then finally, these triggers enable the agent to run a thread of reasoning over time, which is a completely new capability. This is not going to be demoed here, but it's used for the agent to gain confidence over time, reduce false positives, and really run an investigation on what's happening in your environment over time. All right, so let's now go and run our first demo. So the agent is really smart enough to know if there's PII or credit card information in a message that it could, and it knows that it could be an operational risk. So it should be triggering an alert if a developer adds a new log message with that information, and it should try to automatically redact it. So let's go enable PII leaks in our application. So this is going to start emitting logs that have PII information. Now we're going to go to PagerDuty, and here we're going to wait and see if the agent is actually going to have that problem. See if it detects it. Make sure I'm looking at the right service. All right, it detected the leak, actually detected 2 leaks. Let's take a look at one of these. First, let me acknowledge them so they don't keep beeping. And let's take a look at one of these. PII and PCI data leak in the checkout service logs, name and credit card number, PII and PCI leaks, the checkout service, and so on. The log message contains customer names, example customer, Karen, card on file, etc. And so notice that this is a log message that actually doesn't necessarily look exactly like what something could be, or like what a regex rule might be able to find. Let's go find this information inside Datadog to actually see what it looked like. Now here are the messages with the problem. As you can see, the agent also inserted a rule to start redacting the info as soon as it was able to get a decision on what happened. Let's go look at, so here's what the original data looked like, and here's what the redacted data looks like. Now going back into the Grepr pipeline and the Grepr information of what's going on, we can see that Grepr added a couple of rules for masking the PII information. And so here's some actions that it has taken based on that. This is important because when we're talking about sensitive data, context is really important. A message can be leaking sensitive data that can only be understood from the context. So for example, if you literally type SSN, like ESS, ESS, ENN, and then some numbers, the agent can still detect it because it understands that even though this doesn't look like something a regex will capture from the meaning perspective, it actually is a leakage of, say, a social security number. So now for demo 2, what we're going to do, let's go back, turn off this leakage detection. So now looking at the second demo, what we want to do is we have a bug in the system, and we're going to roll out this feature where for a particular item, we're no longer charging the customer. And so the company is actually losing money, and the only way to really detect this issue is by figuring out that we have a missed payment charged log message. And so in our application, we emit a few log messages for each purchase. There's a payment initiated, the payment charged, and a payment completed log message, and those 3 constitute a complete transaction. But if the charged message doesn't appear, and we still get a completed message, that means that we missed charging the customer, but we ship them the items for free anyway. So let's ship the bug, which triggers after a few successful purchases that we're going to do next. All right, turned on. Now going back to our application here, we're going to go and trigger this purchase over here that has the problem. All right. Checkout, that's the second one. And then we're going to do one more. And one more just in case. All right, let's see if Grepr detects this issue. These are the old PII ones. We've already resolved them. Let's see if this problem gets detected. Aha, it found it. All right, so the issue was triggered. Here's the payment, the problem, checkout workflow completed without payment processing. This is really a semantic bug. Checkout workflow completed without payment processing. It's a unique problem, and it's a pretty hard problem to detect using just normal rules today. The system automatically figured this out. You didn't have to tell it that you have to watch out for this payment processing missing logs. And this is really the core of how Grepr prevents escalations, by being able to understand leading indicators of what's happening in your system and in your application, and notifying you or immediately taking remediating actions based on what's actually happening in the system. So we didn't show everything that the system has. It has the ability to learn over time and get confidence in whether or not something is an issue. And let me resolve this one. And it can actually request information over time. It can request adding and collecting more information over time so that it can gain confidence in whether or not something is problematic or not problematic, and ultimately reduce false positives. So we'd love to show you more deeper capabilities if you'd like. Please set up a demo with us. Happy to walk you through it.